Good afternoon. My name is Randy Stott. I'm the managing editor of Gear Technology magazine, and I'm here today with Dr. Hermann Stadtfeld, who is Vice President of Bevel Gear Technology and R&D at the Gleason Works. Thank you for joining me, Hermann.
Thanks for having me.
Today we're going to talk about what makes a machine tool company in the traditional gear business successful in 2017 and beyond. And so I have some questions for you. And traditionally, machine tool companies earned their success in the business by making their customers more productive and being able to produce more gears faster. Are we getting close to the limits for how quickly we can cut the chips today?
You know, the normal answer, because it seems to be human nature, is to say, yes, we're getting closer and it's almost everything used up, all the possibilities. But I think differently. If we just look back 5-8 years, we actually increased the cutting speed by about 20% due to three-phase technology, better coatings, and a more smart way of using our tri-cutting technology. So I believe that better tool materials like a ceramide or a better carbide combined with a new coating, a real quantum leap, in the morning we talked about some of those, that they will actually enable us to run the spindles twice as fast, so to use twice the surface footage, which actually would obviously reduce the cutting time to 50% of the original cutting time, but it also, then people would ask, yeah, but that brings you that to the limitations of machine tool capability. And it's the opposite. As faster a spindle runs, the more inertia you have, or the more kinetic energy you have. Mm-hmm. And we made the experience in the first step from wet cutting to dry cutting, where we run the spindles almost 4 times as fast. That cutting processes went smoother, gear qualities were higher, surface finishes were better. Mm-hmm. So I think there is a lot of potential still left.
Okay. What about moving the parts in and out of process in the automation? Are we close to the limits for how fast we can get things in and out?
I think in that case, if you watch at some of those automation systems, in that case my answer is, yeah, we're getting to the limits. Mm-hmm. Because no automation manufacturer can break the sound barrier, but they are already very close to it. Mm-hmm.
So, in addition to what you've described, are there any other places where future productivity gains will come from?
Productivity gains, like I said, you know, the different tools, faster surface footage possibilities, maybe more smart three-phase blade technology that we really greatly developed during the past years, but also productivity gains, or let's put it the other way, tool life increases, tool life improvements will always lead to some productivity gains, because mm-hmm. you have take the tool off the machine, put a new tool on, and requalify the first part again. And if you can stretch that out with twice the tool life, that is a productivity gain as well. Sure. So some of that will come from that.
Okay, very good. I would also like to explore the importance of Industry 4.0 and the industrial Internet of Things to the future of Gleason's product mix. So in what areas are you working to develop these concepts?
Yeah, we actually do have active projects, 4.0 projects. We add more sensors to the machine. We use the already existing sensors for temperature, for vibration, like torque mm-hmm. Signals, etc. We use that in order to optimize the process. To, for example, a process that runs a little rough or that has some measurable disturbances, to change and retune the parameters to make the process run smoother. Mm-hmm. That's actually an active project. We have a series of, let's say, projects or features. They, for example, called G Tools, G Production, G Design, and so on. And those are, for example, if I had the G Production feature on my machine, then, for example, optimizations would be happen that are according. One good example is G uptime. Mm-hmm. Like, for example, the machine would sense when a rail or a truck or a ball screw or a spindle starts to wear out, due to the constant measurements that it does and the part count, and find that the end of the life of that spindle, of that component, is like 3 months out, it would give you appropriate warning messages so that the downtime of the machine could be kept to an absolute minimum.
And what are the benefits of introducing Industry 4.0 concepts to the gear manufacturer?
There are many benefits. First of all, people expect today that the 4.0, the smart factory, all those are buzzwords that people like to throw out, and that people like to actually work in that with those schemes and with that momentum that is there. That's the one thing, that it's modern and people would like you as their machine tool manufacturer to utilize those technologies. But then again, if you had a mass production and you would produce tens of thousands of parts with the same geometry, maybe then some of the 4.0 ideas are not so important. But look at the small manufacturer, like the G process. If the G process feature is turned on, it would, even if you only make 5 parts, optimize your process. So it's actually nothing that is only for the large scale manufacturer. It's even for the medium size or small manufacturer for a real tangible benefit.
Very interesting. You're Vice President of Research and Development, so I'd like to ask you, why is R&D such an important part of what Gleason does?
Like you said, a machine tool company in a traditional business, like gear manufacturing, with a tough market, is expected to come always up with new ideas and come up with additional new high-tech solutions. So Gleason, for example, has more than 300 active patents, worldwide active patents, which is much more than many of the companies our size have. And I believe that the new developments, new processes, new process ideas, like we came up with new tooth forms, tooth geometries, even kinematics, new process kinematics like our Unimill process, and things like that often are expected. Somebody buys, also again, the medium-sized manufacturer buys a new machine, and he or she is now able to say, I can utilize that machine for the new products that I have, but there is some time left, and there's possibilities to, for example, power skive on the machine, or with Unimill make prototypes on the machines. And all those are really new high-tech developments that we have patent applications on that protects our IP and makes sure that we are a market leader.
I assume that customer demands shape a lot of what happens in R&D, and my next question is, what are customers demanding of you next? What are they looking for?
What are they looking for next? In the past, our developments were always driven by customer demands. The customer came and said, we like to try cut. It wasn't really our idea. We made it happen, the try cutting, and we made it happen real well. The customer said we like quieter gears, and we came up with a universal motion concept and additional other optimization possibilities. Now in the future, I see things like, for example, soft cutting, heat treating, and grinding or hard finishing in the same machine or in a group of machines that are connected. Or we have some projects that are coming up on the horizon with machining hard material that is already hard, and then machine it out of one part in order to save handling the part between different machines in a heat treat facility and so on. So I think that those kind of solutions, that they will come up more and more. But also combinations like with additive manufacturing, like for example, some parts or some elements of the geometry of the part produced are done the conventional way, and other elements are produced with additive manufacturing. It may be interesting to mention in that connection that Gleason has one of the first and only patent applications for gear manufacturing, really teeth manufacturing, cylindrical and bevels, with additive manufacturing in steel, with plasma welding.
Very interesting. Gleason has made a number of acquisitions over the recent years, and these include different aspects of the gear manufacturing process, from inspection and work holding and automation, and most recently plastic gears and software. And how do these expansions in the scope of what Gleason does help you become a more successful machine tool company?
I could answer the question that you already said the answer, because looking closer at what you said, you cannot really cut a gear without that you had software to calculate the gear. And when you manufacture the gear, you need tools. And when the gear is done, you like to 3D measure the gear or have some other kind of metrology for that. And the plastic gears are just gears that are made from a popular material that is very suitable for a number of very modern applications. So it really all fits the portfolio of a total gear solutions provider that we like to be.
Very good. You mentioned additive manufacturing and the work that you've been doing there. Are there any advancing technologies that are a threat to traditional gear machining?
You know, the technology is not directly the gear making technologies. I see that, for example, electric vehicles have lesser gears than our today's traditional vehicles, and that public transportation and others will kind of take away the number of gears manufactured. However, Gleason has also partnerships, development partnerships with several electric vehicle manufacturers to come up with modern solutions for making the electric motor run more efficient by having a geared solution, and also the recuperation of the energy by braking, etc., to make that more efficient.
Very good. You started to talk a little bit about electric vehicles, and this is one of the answers to the next question, but what significant changes are going to shape the gear
electric
industry?
vehicles, maybe more public transportation, and then the general trend, you know, that gear, of course, the 3D printing as well, additive manufacturing, but also the trend that you see also in the United States, in every other Western country, that more products go to popular low-cost manufacturing countries. However, I see that, like I mentioned before, also in electric vehicles, gears are used. But there are today, more and more, many new consumer products, industrial and consumer products, that use more gears than in the past, and that use actually other gear forms that might not be traditional gear forms. There is also the notion that we find many we call them index symmetrical parts, that almost look like gears, but they aren't. But you need the knowledge and the manufacturing technologies of gear manufacturing. So all that will somehow compensate. And I see an additional trend already today with several large manufacturers, also here in the United States, to get product back from those popular low-cost countries because of quality, of delivery times, of control over the product and the product design. So I think in 10 years from now, we're going to produce the same number of gears, but some of those gears, they look quite different than today's gears.
Very interesting. Dr. Stadtfeld, thank you very much for your time. I appreciate it.
Thank you for having me.
Very good.